Hello and welcome to lesson 1. This is going to be our first lesson for the year. We'll see how this whole online recording platform goes, but we'll try to make this at least somewhat fun. So I have a couple screens here, so if I'm looking this way, that's why. So looking here, we're on 0.1. That'll be solving equations. While you're taking notes here, there's going to be times when I say, hey, go ahead and pause me. I'm going to ask you to be looking and trying to finish problems. This is a lot of review from last year, so make sure you try to do that. I know it's tough, but when I say pause it, please do so. Just pause it and finish the problem, and then resume me, and it'll go just fine. Okay? If I were you, I'd have a calculator around, something that you can actually use to do these problems. I probably won't be showing my calculator up here very often, but I will be using it in case we need it. Okay? All right, well, let's get started. So to start geometry for the year, what we're going to actually do is we're going to work with solving equations. Okay? So, as the year goes on, obviously solving equations is not all geometry, but it is going to be very important that you can solve equations in a reasonable manner so that we can actually get the geometry done as we go forward, okay? So to start with, our essential question, we'll write it right here, right? Essential question, how do I solve equations? It's been all summer, I haven't written that much. Okay? So all year, you think about this. If you can't answer that question after the video, or if you have no idea how to answer that question, then you need to let me know, right? I haven't done my job. So, a couple steps that you can do when solving equations. Step 1, use the distributive property. If you recall, it looks kind of like this. You have something times something plus something. So this is A times B plus C. When you distribute this in here, it is this double arrow thing right here, right? So this turns into A times B. This plus remains, and A times C. Okay? We've distributed a bunch in previous years, so I don't think we'll have any trouble there. Okay? So I would distribute first, combine like terms on the same side. So on the left side, combine your terms. On the right side, combine your terms. And then use inverse operations to solve for the variable. So what that means, I'll try to do this in purple. If you had x plus 2 equals 5, inverse operations means what do I need to do to get rid of this 2? Well, if it's addition, the inverse operation of addition is subtraction. So what I need to do is I need to subtract 2 on both sides, and that eliminates that 2, and I end up with x equals 3. Okay? So that's what it means by use inverse operations to solve for the variable. Okay? So hopefully those things all make sense, right? What this says right here is the inverse operation of addition is subtraction, and the inverse operation of multiplication, well, that's division. Okay? So we're going to go semi-quickly. When I post these notes, I will have them all filled out. I do not believe that we will go through all of them in this video. I'm trying to keep the videos about under 10 minutes, and so I want you to get the most out of the videos that you possibly can, okay? So as I go along here, I'm going to do a few just flat out through them. Some of them I'm going to say, hey, go ahead and stop me here, finish it, and go on from there, okay? So for number 1, we have 4x plus 5 is equal to 9. So our goal, of course, is to solve for x. So the first thing that we should do, okay, is distribute. Well, there's nothing to distribute, so that doesn't make any sense. Okay, so then we use inverse operations. And so the first thing that I would recommend doing is subtracting the 5 on both sides. So subtract 5 on both sides. I end up with 4x, the 5's cancel, equals 9 minus 5, that is 4. Okay. Now, to get the x alone, all I have to do is do the inverse operation of multiplication. So that is division. So I divide by 4 on both sides, and I end up with x equals 1. Box that because I'm super proud of my answer, and that's that. Okay? This should be very heavily review. Shouldn't be too bad, just to kind of, it's been a long summer, been a long COVID, so we should be, doing some math at least. Okay? So if you have any questions, let me know on this one. All right, on to number 2. Pretty simple. We have x over 4 is equal to negative 3. We want to get rid of that 4, but the issue is that it's divided, so we need to do the inverse operation of division, which means we need to multiply by 4 on both sides. Hopefully that orange is okay to see. Yeah, it's fine. Take it times 4 on both sides. These two 4's cancel, and so on the left side we get x, on the right side we get negative 12. Negative 3 times 4 is negative 12. Okay? Not too bad there. All right, one more before I give you a practice one on your own. So number 3 here. We have 10 equals 8x minus 3x. Now, again, you want to look for distribution. Nothing you can do there. and then you want to combine like terms on both sides. So that's what we're going to work on here, is combining like terms. Combine like terms. Okay? So what that means is if you had like a 3 and a 4 that were the same term, so 3 and 4 would be 7, or in this case we have 8x and negative 3x. Those are the like terms, of the same kind of thing. And so we could put those together actually. And so here we leave the 10 alone, and we get 8x minus 3x. Okay, so 8 minus 3 is 5. So if we had 8 x's, took away 3 of them, we end up with 5 of them. So we have 10 equals 5x. Okay, so that's the easiest way to do it. Of course, there's other ways, but that is the easiest way to do this one. Okay, then all we need to do is get x alone. So you divide by 5 on both sides, and you end up with x equals 2. Okay. Make sure when you're doing all this stuff, you keep your work very nice and clean. Okay, I know it's not that important right now on this review, but as the year goes on, the material gets harder and harder, and the work gets longer, and you're going to want to keep your work nice and tidy so that I can read it and so that you can read it. Okay. All right, going on to the next one. I want you to try this one on your own, but figure out what the first thing you want to do is and go from there. So go ahead and pause me, and then go ahead and finish that from there. All right, hopefully you resumed. So let's go through what you did. Hopefully the first thing you did was subtract 2 on both sides. Oh, I should be using orange. I'm sorry. So we have 3/4 x equals negative 1 minus 2. So if you weren't careful, here's where you probably messed up. So negative 1 minus 2 is negative 3, right? Then to finish up here, you get rid of this 4, so you take both sides times 4. And you should have received 3x equals negative 12. And the last thing you have to do is divide by 3 on both sides. So you get x is equal to a negative 4. Now if instead of multiplying by 4 and then divided by 3, you actually took it times 4/3, that would be fine too. Okay, if you saw that, then great. If not, then it's okay. This is an awesome route. So hopefully you got that one figured out. All right, on to number 5. Making good time here. Pick my camera up a little bit. So we have 5 parentheses x plus 2 equals 15. So this is our first problem where we actually need to distribute. So the first thing you want to do is distribute. So take the 5 times the x and the 5 times the 2, just like we practiced up top. And so we get 5x plus 10 is equal to 15. Okay, so now we're back into the previous problems that we just did. So the first thing I would do is subtract the 10 on both sides. 5x equals 5, and then you would divide by the 5 there on both sides. End up with x equals 1. Okay, nothing too crazy about that problem. Box your answers so that whoever's looking at it knows. Okay. Go ahead and try number 6 on your own. This is a negative 36. It just does not look like it, so make sure you take that negative. But go ahead and try number 6 on your own. Pause me right now. Resume me when you're done. All right, so hopefully you finished it. First thing we're going to do is we're going to distribute. So we take the negative 3 times the 4x and the negative 3 times the negative 8, which is where I would imagine you messed up, right? Negatives sometimes cause us to not be very careful. Okay? So we have negative 12x plus 24. That's the negative and the negative combine, right? Equals negative 36. So now we're back to a normal equation. We can kind of work from there. So we subtract 24 on both sides, and we get negative 12x is equal to whatever negative 36 minus 24 is. So that should be negative 60. Okay? Lastly, to get x alone, we divide by negative 12 on both sides, and we get x is equal to a positive 5. And that's that. Hopefully you received that before you actually watched me do it. Okay? So hopefully, and if you have any questions on any of this, what you should do is if you're really stuck, if this question was super hard for you, you need to be circling that number 6 and asking me about it in class. Okay, that's what our class time is for. You should ask questions about this and the homework that we have together. Okay? So on to the second page, almost done with the first lesson. Should make about the 11-minute mark. Okay, we'll do 2 of these. The other 2 you can do on your own. So we're going to do 8 and 10 here. I would challenge you to do these on your own. So do on your own. I will post these finished solutions, if you will, eventually, but I want you to try these two problems on your own. They're going to work exactly like these for the most part, but they're just a little bit more practice to see what you can do. Okay? So for number 8 here, the first step that I would do is I would combine like terms first. You do not have to, and if you don't, that's fine. But I would do x and 5x, those combine to be 6x, and 20 and 10, those combine to be 30. Okay, so we have 6x plus 30 is equal to 180. Alright, so now we get x alone, subtract 30 on both sides, and we get 6x is equal to 150. Divide by 6, x equals, pretty big number, go ahead and find it. I'm going to do the same, and we get 25. That makes a lot of sense. Okay? So something that you could do if you weren't very confident, right? Not required. There's no reason we'd have any solutions like this, but if you weren't very confident in your solution, what you could do is you could take it, plug it back in to make sure it actually works. Okay? All right, on to the last one, number 10. So this is a little bit tricky because depending on which option that you pick first, it makes it harder or makes it easier, okay? So I'm obviously going to go the easiest route because I know what I'm doing here. But if you, for example, if you multiply by everything by 6 first, that's an option that you actually have, okay? So just be careful. We're going to subtract the 2 first. That's our first step that we're going to take. There are other steps you could take, but that's the easiest one. So we end up with 2x plus 3 over 6 is equal to 3, right? This 2 and this 2 cancel. Now, it's very similar to the first page. Take both sides times 6. And these 6's cancel. We get 2x plus 3 is equal to 18. Go ahead and subtract 3. You get 2x is equal to 15. Not a very nice number, but we end up with x equals 15 halves. If you want to put 7.5, feel free. I prefer fractions, honestly. Fractions are nice, so I'm okay with this number. Really up to you. It doesn't really matter to me. So that's going to be the end of the problems that I do. Please do 7 and 9 on your own. But a couple of things that I kind of want to bring up here. So first off, I want you to write a short summary here. I'll be checking these in your notes when we come back next week. So go ahead and make a summary spot. I want you to write one thing that was review. I want you to write one thing that was scary. And 3, okay, the last thing I want you to write is what was the hardest problem? Spelled hardest wrong, sorry. What was the hardest problem out of all of these? And then why? Okay? Those 3 things I want you to write on your notes. Okay, you have plenty of room here. Okay? Last thing before I let you go, a couple things the students always ask me. Do I need to show this minus 3? Do I need to show this times 6? Do I need to write that minus 2? For this lesson, please do. Okay, from here on out, I will never make you do that again. But when we're first, I'm making sure you know how to actually solve equations. I want to see those steps actually written on your paper so that I know that you know what you're doing. Okay, so on your homework, please do it this time just for me. I know it's obnoxious, but it'd be super helpful. Okay? That will be the end of lesson 1. Let me know if you have any questions, but otherwise, have a great rest of your day.